We're both Stefan Esser.
And we're here to teach you PHP 101. So,
well, we already said the main thing, right? So all you really need to know about PHP is that it sucks and you shouldn't use it. So, I mean, I can't see having a 75-minute talk that goes beyond that. So you could have walked into the room, it sucks, and you leave. So this, you really know who your friends are when you know, you're talking, everybody's like, hey man, it's great to see you, I haven't seen you in a long time, I'm really looking forward to your talk. And they say, what time is it? Oh, it's like 10 a.m. And they're like, oh, screw that, I'm not getting out of bed. So that's kind of how it is today. I think our proctor actually took a dive and slept in late on purpose so they didn't have to pronounce his name. But I am Nathan Hamill. I am a, yes, it's pronounced Hamill. I'm a principal consultant on Fishnet's application security team. I'm also a professor at the University of Advancing Technology. That's how I met this guy originally. And
my name is Marcin Wielgoszewski. I work for Gotham Digital Science as a security engineer. So kind of the goal or theme of our talk is that you can't just rely on your standard toolkits anymore. You know, there's many more people testing web applications than have ever been testing before. A lot of these people are coming from backgrounds that aren't development. A lot of them have been managing firewalls and everything else, and they haven't really gotten down to understand these problems. So it's really up to the person doing the testing to ensure that you have proper coverage, that all of your bases are covered. There's also difficult cases too, where standard toolkits fall flat on their face, or they're, you know, don't have any visibility into what the application is doing. So you have APIs and specialized data formats and protocols that your standard vulnerability scanners just don't understand. You also have things like sequenced operations and randomized data. So if you can't replay an attack, if a tool can't replay an attack, which is about how a vast majority of tools work, then you're not going to find the vulnerabilities. So basically, we want to have an intervention. We want to have an AppSec intervention. So the people who are out there that are just getting into AppSec, they need to learn at least what object-oriented programming is. So building block. And then one more slide here. So this is kind of a modern infrastructure slide. And if you look, we have our rich contents, we have our web front ends and back ends, and we have APIs and fat client apps and everything else. Well, if you think about like how deep your web scanner is going, it's not even hitting, you know, all of the front end potentially. Like your web scanner that you're using might not even understand anything that the Flash is doing. So in that case, you're really not hitting the big picture. And the theme of our talk is that at some point you're going to have to write your own test cases and clients. And that's what we're advocating, and I don't think anybody's really disagreed with us. I mean, even scanning vendors aren't going to tell you that their products are 100% effective at finding vulnerabilities. So why we choose Python? I like it because I could rapidly develop various test cases and tools. You know, you can whip up something in like 30 minutes that does some really cool stuff. It's really easy to understand, so especially when you're like looking at other people's code, real simple. I like the white space. Some people are Nazi about it. I like it. So.
And there's plenty of help and support available in the language as well. Like, so show of hands, who here has ever written anything in Python, even if it's like Hello World? So just about everybody. Well, that's good. How many people here have ever written anything in Perl? So how many people in here wanted to punch themselves in the face after writing something in Perl? That should be just about everybody. If you enjoy using CPAN, then you are a sadist. Nobody likes CPAN, and they still use CPAN. It's crazy to me. I mean, even, you know, Ruby has gems, Python has the easy install disk tools, so it's time to move on to a better language.
So there's tons of tools out there already written in Python. Some of the big ones you probably are familiar with, like Peach, W3AF, web scanner written in Python. Those of you guys coming from like the network side of things probably are familiar with Scapy, which is an awesome library that's like showcase of like Python and security and network type tools. Those of you coming from like reverse engineering side, if you use IDA, there's like IDA Python, there's PyDBG and PyMay stuff like that. It's just awesome.
So you might be wondering, you've heard us talk that there's problems with modern testing tools. So you might be wondering where Python would fit into your testing strategy. And it fits right at the point where you're verifying vulnerabilities, the things that are faster to do, like scripted together than you could do manually. Because it's feasible to go through the website and test every single input by hand. Now, I don't know why you'd want to do that. It doesn't seem very effective. And if you're like a consultant, you'd probably lose your job, right? Because it would take like 6 months to test a single app that you could have tested in a week or 2 weeks. So that's where Python fits, right there in between your manual analysis tools and your fully automated scanning stuff. There's a couple different Python implementations. We just highlighted like 3 major ones. CPython is the main version of Python that you probably think of. It's written in C, it's fast. Jython has been around for a long time too. That's actually Python inside of Java. And on the flip side, IronPython is Python inside of .NET. Other than just having an excuse to put Ron Jeremy in our slides, this is about whatever language you choose. Like say I don't know why, if you weren't interested in Python, first of all, I don't know why you would be here, but if you decided to use something else, you want to make sure that the capabilities of the language match with what you're trying to do. You need to be able to speak the language of the application. So if your app needs to understand like SOAP, then you need to have something that can construct SOAP. So whatever data formats, whatever languages, it needs to speak. If it needs to speak HTTP or some other binary protocol, you need to make sure your language can speak that, and that's what this is about.
So some of the modules you'll run into constructing clients and writing Python tools. There's HTTP lib and URL lib. Those are probably the most common ones you're going to run into using. Some of the third-party ones that you might not know of that are real useful is things like HTTP lib 2 and URL lib 3. Excellent parsing library out there is LXML, as well as there's some other things for other formats. So.
And what we're distributing here, and it's actually available for download right now. I know it was kind of dumb not to show you the URL for it, but along with this talk, we have a zip file that contains all the tools that we're releasing today, and just example code snippets that you can go and like refer to for different things. So that'll be in the zip file. We're not going to spend a lot of time talking about that. The only thing I'll mention about URL lib2, the important thing is that it's extensible. So you can extend it to add new protocols as they come along. You might be wondering, too, when you start constructing, especially if you start learning a new language or whatever, if you start constructing your clients, you're making changes to headers, you're making changes to content, you might want to see what the server would see. So I wrote this little tool called reflect request, and it's in the zip file. And all it does is any get, post, put, or delete you send to it, it echoes it directly back to you. And when I was writing Monkey Fist for last year's Black Hat, I needed a way to see if the CSRF attacks I was generating, like what the server saw. So I ended up writing it there.
It's basically just trace in Python, 4 lines.
So data representations. Anybody who's ever done any web testing knows about encoding in different formats and data representations. Sometimes browsers like IE understand different encoded formats versus Firefox. So Python has string methods just like any other object-oriented language. So every string in Python is an object. One of the features you can do is .encode. So if you did like string .encode, base64 or hex or rot13 even. I know rot13 sounds kind of funny and we all get a chuckle out of it, but just 2 months ago, we were doing an assessment on an application that was trying to obfuscate URL paths using rot13. And it was painfully obvious because you'd see like dot, or colon, / a bunch of weird characters, and so it's pretty obvious. Dharma encoder is a tool I wrote because I like having a standalone encoder, and I like also wrapping values in text. So the magic of Dharma encoder is in the encoder lib, and so if you wanted to know in Python how to represent data a certain way, like there's SQL character encoding and Oracle encoding and a bunch of other things in there. You can just look through the encoder lib on the Google Code site and see that all you want. So screenshot. This is basically what it looks like. It's a PyQt app, and you can have a drop down, change different things, and you can also wrap it in like script tags. I guarantee that there's bugs in this because I wrote it. So please tell me if something's broken or something you want something in it, and we're not going to spend too much time on that.
All right, so when you actually get responses from the server, the most common formats you're going to run into is like HTML, XML, or JSON. The library that you want to use when parsing HTML or XML is LXML. The nice thing about it is, like when you run across like malformed HTML, lots of parsers out there will break as soon as it detects invalid markup. Whereas LXML will actually handle the invalid markup for you. And you may be familiar with like other modules like Beautiful Soup or HTML parser or a couple others. Reason why we don't recommend you guys use these is because they're not as fault tolerant as LXML. They're actually written in Python, whereas LXML is written in C. LXML is a lot faster when it comes to parsing content. And the author of Beautiful Soup expressed not wanting to continue supporting Beautiful Soup. So he kind of recommends everyone actually use LXML instead. It's actually a nice library for XML parsing. And the other library for parsing things like JSON is actually JSON.
Yeah, and everybody in here knows that the web is like broken just a touch, right? So like if you go run Python's HTML parser over the top of it, it's going to break horribly.
So just parsing some simple HTML content like that we get from a server. Say we want to iterate over every link in the document. We just iterate over every A tag and just get the href attribute from it. It's simple as this, like literally 3 lines of code, we're done. Some other use cases I find XML parsing really useful, especially when I'm doing like code reviews and code review assisted black box testing, is like parsing out web XML files. So getting like the servlet names, servlet classes, and the URL patterns that they map to, so that like I could just dump it out into like some Excel spreadsheet, and as I'm like testing, I like mark down what I tested, what I haven't. So this is an example that just uses XPath expressions to get the actual values of the elements in the web XML file. So it's relatively simple.
JSON is kind of interesting because JSON actually maps almost directly to Python types. So a JSON object is basically a Python dictionary, and a JSON array is basically a Python list. So it matches up pretty well. So in a couple lines of code, you can go ahead and rip things out of JSON. This is an example code for just hitting the Twitter API and pulling all the current trends. I guarantee if you run that code right now, this talk is probably not one of the top trends on Twitter. It's probably like Britney Spears again for some reason. I know Britney Spears like is 1995 or something. So for fuzz cases, one of the most common things you're probably going to want to do is web fuzzing. But rather than just taking this brute force approach and just ripping through the app, you want to do some intelligence on it. You want to make sure you understand what protocols it's speaking, because one, you're probably going to want to violate them, and two, you're probably going to want to stay within the protocol when you're doing other types of testing. So you want to know your parameters, you want to know what data that it accepts, and really do your homework on it.
So one of the things I run into with scanners, a lot of them try to throw everything at once at the application, like fuzzing every single request. The downside to that is, if like 2 parameters end up blowing up, you're not going to end up going deep into like the code path, and you might not be able to explore all the various paths through the application. So just be smart when you're generating these fuzz cases. Just do one at a time. A great module inside the standard library is iter tools. There's various methods in iter tools that let you create like fuzz cases very easily. And this is just some example. Say we have like a list of parameters and just a list of attacks. We could create a Cartesian product using the iter tools product method to then just fuzz every request parameter one by one, instead of throwing everything all at once.
And iter tools is specifically made to be more efficient than your standard for loop, because it's made for iteration, hence iter. So everybody's got that. I know it's early in the morning, but. So PyWebFuzz. I wanted to have a module where I could call things out of. Originally, I just wanted to implement the FuzzDB and say, you know, I want to be able to call FuzzDB inside of Python and be able to take advantage of all that. Has anybody here ever heard of FuzzDB? Okay, FuzzDB is basically a collection of values. So it's your data files. And so when you're doing SQL injection, it's nice to have a list of, you know, predetermined SQL injection values to test. There's a lot of other things inside of FuzzDB too, like error strings, which are kind of nice, and you know, exotic encodings and all kinds of things like that. So it's nice to have those inside of your test cases where you can just call them. It started to become like a lot bigger than I intended. So I have the FuzzDB values available. I have request logic that's built into the utils, as well as I took the encoder lib from Dharma Encoder and included it here as well. So you could grab any of those encodings and run with them. So I guess I really don't want to pop out of this. Okay, so we're going to have to do it eventually anyway. So just to pop out of this for a second, on the Google code page, there's the wiki, and the only real important thing that you need to see here is the import of like the LDAP values from FuzzDB. Now, I realize that this looks very annoying, but I was trying to map the namespaces as close to FuzzDB as possible, because if you're familiar with FuzzDB, then you know, having to learn new paths and everything else. The only other thing is that anywhere there was a hyphen in FuzzDB, I had to replace it with an underscore. So, and that's pretty much it. Yeah. So another place where you're going to need to write your own tools is where you have complex sequenced operations or state issues. Your vulnerability scanner might not understand how the web page is being laid out. I've seen instances where every single time the page is laid out, you'd have your menu options up there, and underneath those menu options, there's a different random value associated with them every single time the page is laid out. Every single vulnerability scanner, every single tool is going to choke on that, because many of them work by replaying attacks, even if they're updating cookie data and everything else. So home is not the same location every single time you click on it. In that case, you have to maintain your own state, you have to call the content, and when you start building your own tools, you start to take for granted some of the things that other tools or even a browser does for you, such as, you know, appending the referrer onto the request. You know, those are the kinds of things you need to think of when you're building tools from scratch. And of course, if all else fails, you can resort to regular expressions, which
then you got two problems.
So sometimes, you know, it's easier to have the browser do work for you. And there's a couple different browser automation frameworks. Has anybody here ever heard of Selenium? Oh, wow, quite a bit. Okay, cool. Has anybody here ever heard of Windmill? 2 people, I'm actually surprised. So Windmill is basically the Selenium idea with like Firebug Lite and everything built into it, but it's written in Python, which at first I thought was kind of cool until I started using it, and then I didn't like it anymore. I just had some problems with it, and I ended up just going back to Selenium. So one of the things you can do with Selenium is walk the browser through a particular case or problem, and the IDE will record all the actions for you in your associated programming language, and you can just copy and paste that data into your IDE and make changes as necessary, and then rerun that test case. And Selenium will launch the browser, it'll walk it through everything, and it'll send all your test cases. So there's a couple of different components to Selenium. There's the server, which is basically written in Java, that sits there, listens for the request to come in, and basically runs and launches the browser. The remote control, which is your Python interface, so it'd be selenium.py when you download the code. And then the browser plugin, it's a Firefox plugin. So next slide. It kind of looks like this, and we're actually going to do a demo. So, and I hope it's okay to see. But as you can see, you can see Tom Selleck there sporting his mustache. So as you can see, we have a bank website opened up here, and as you can see the Python code on the side. I'll just do the demo. And I'm going to hope that that this is easy enough to see for you. Oh wow, that's not going to be good, is it?
Can you expand it?
Yeah. So that's not good. I can't drive, by the way. So here we're gonna end up testing this bank website. So we're gonna launch our Selenium IDE. It's gonna come up, and then I already had Python selected. But if you go into off the screen, you can see that Python is selected, and I moved it even more off the screen, which is awesome. It's not off the screen any other time. So you might have an operation where you need to click through 3 different things before you log in. On the side there, if it was even remotely visible, you'd see that it's building these actions.
So it's actually generating Python code on the fly.
Yep, it's generating your Python code. So even though our login failed, like our test case fails, right? We have all this code set up here. Inside the Python file here, you copied and pasted it in. I just added a for loop over the top of some attacks. So you know, a semicolon, a single quote, a semicolon, and then a 1 = 1. So we start the server up, and then we just basically run our Python code. And when we do this, once we run this, it'll actually take care of in the background. It'll start the browser, and it'll run through the actions that we recorded in Python. And of course, I broke into it and added some SQL injection attacks. And for convenience, there is this running, I said there's a function that says get body text. And I figured that was easier than having you strain your eyes to look at a bunch of HTML. So if we scroll up the 3 test cases we did, as you can see in the first one, we see a database error message there. So that's probably not good. The second one looks kind of like the normal website that failed. However, the third one says view account summary. So that's like win. And that did not take any time to do that. So if this bank was a difficult case where we had to click through and take all these actions, it's much faster than clicking through all of them and then adding the data yourself. So this can be very useful. And of course, this didn't even hit the tip of the iceberg with what Selenium can do, obviously, since you guys are familiar with it. How many people knew that you could do this with Python and Selenium? Okay, a few people. Good. And you guys are so in luck because you get to see Tom Selleck again. I just want you to take that in.
So the way I work, basically, when I write tools, I don't try to do any kind of spidering because I think it's too difficult a problem for me to actually just handle myself because I'm not that smart. I'd rather just work off what I already have, and that's from like a burp proxy crawl log. So like as I'm browsing through an application, I'm having like burp record every request and response to just some log. And this log contains like a lot of valuable data that I could then use. So I wrote this API basically, I call it the GDS Burp API. Basically I go through and parse an entire burp crawl log, or you could parse a spider log or any kind of log that burp generated, and parse every request and response into a single object. And that each burp object contains the properties of the request and response, as well as some other metadata that burp recorded. This is just a printout of various values inside like a burp object. A couple things to note: there's like an index property. If you have like burp open, if you look into the history, that index in the burp object is going to match to the number, the index number in your burp history session. You have full access to like the request body, the request headers, request method, response body, and things like that. So why I wrote this was because like using web scanners, Ben Nagy told this the other day about fuzzers. Everyone writes their own fuzzers because everybody else's fuzzer sucks, right? That's why I write my own scanners, because I don't work the way some other people work. So these web scanners, from my opinion, never provide enough context to the requests and the responses that I want. They try to do too much for me, but not as much as I want them to. So basically, we could take this API and just build our own smart fuzzers or scanners on top of it. So what can we do with the API? One of the things that I like to do is, say you take 2 user sessions. Say one person's like a user and the other person's like an administrator. What we could do is we could parse those 2 separate proxy logs, compare all the URLs that were accessed, all the parameters that were submitted to with each request, and do a comparison. And what you'll find is probably the administrator probably has a lot more access to various URLs and parameters that get submitted. So what we could do then is just take that burp object and just replay it as a normal user. Things like inspecting responses, comparing content length of responses is real simple. Another nice thing that I came across while writing this API is basically I can pull out from my parsed list of requests and responses individual requests to replay. So say you have some cart checkout operation that may take 5, 6, 7 requests. I could pick those out and replay them in order and fuzz them along the way, submit requests out of order and see what happens. So it's a lot, I think it's pretty powerful.
Also login too, like a login sequence.
Yeah, so like a login sequence as well is perfect. And just replaying a request with HTTP-lib2 is as simple as these literally like 3 lines of code. So another nice thing is inside the Python standard library, there's a module called difflib. What we could do is we can now compare, we can output a diff comparison of 2 responses and easily identify the differences in the HTML so we could visually see what has changed in a response. So I got a demo for this, just showing it off.
So we're going to assume the same problem is happening, so I'll drive.
Do you want to zoom out?
Yeah.
Like, zoom out in the video.
I can't zoom out anymore.
No, I mean zoom out, not zoom in.
I can't zoom out anymore. It's on the screen.
Can you right click?
So, you know what? You're just doing this page anyways.
No, I'm not. It's the other side.
Oh, it's the other side you want.
Yeah, so basically I just have a open proxy log. Yeah, sure. I got a proxy log on the right that just burp recorded. Here I'm just importing the GDS Burp API. I'm just importing some the logging module just so that we could see some output as we do this. First thing I'm going to do is actually parse the burp log. It doesn't take much time at all, really. Then I'm just going to show off some properties inside a burp object. We have the full properties of what burp recorded. You want to call a method like get request headers on a certain object, get that. You could call it an individual header. So we have a documented API for this. So here now I'm just going to actually fuzz all my requests, and each request gets each fuzz request gets actually appended to a replayed list for every individual burp object. So I could then call like the 5th element in the replayed list, the response headers that were fuzzed. Here I'm just doing like a diffing the responses of all the requests. And this is just shows easily, just visually why it's changed. Right there I'm just highlighting a script alert tag got inserted into the body compared to the original request. This one here, there was a set cookie header on a or 1 = 1 in a password field, and there was an actual redirect in the response. So that's a win, I think.
Mm-hmm.
So it's really a lot of cool things you could do with just a couple lines of code using the API. Another thing I implemented was a save state feature, which allows you to save all this data to just a single file, so then you could then later reopen it and have access to all those properties and values in your scanned requests.
You just showed saving and reloading state, right?
Right. So here I'm just accessing the just a replayed request and just getting response headers again, just to show.
So this is in the zip file too. Actually, I probably have that open. So just really quick, there's the docs portal on, it's just hexec.com/docs, like the updated presentation, because the one that's on your conference materials, like everybody else's, it's like horribly out of date and probably not even remotely the same. So you can grab the docs and the constricting code snippets as of right now. So hexec.com/docs and should point you right to it. But we did that like literally minutes before, so there's like no descriptive information on there. Okay.
So like I said, you can save state, load state. Parsing logs is about like a minute per 100 megabytes, depending on how fast your machine is. It's relatively fast, so if you find ways to make it faster, I'm all ears. I'm all performance here, not security. So that's the way I work when it comes to like doing burp stuff. So, you know, if you want it, take it. If not, you know, you can do other things. So it's all you guys.
Yeah, I love how black and white that is. If you want it, take it. If you don't, whatever.
So
I love how that picture was just taken with me going. I look like, it's like, what is he talking about? It must be really interesting. Another thing that's useful too when you're testing web applications is, since the browser is what renders all this stuff, it's nice to be able to integrate into the browser. How many people knew you could write extensions for Firefox in Python? A couple people. Okay,
5,
very good.
6.
How many people have ever done it? Is that
3.
another one of those punch your face things after you're done? It can be a little difficult. One of the reasons why I quit doing it, because I had written a couple of standalone Zool runner applications, I didn't have enough access to the browser object without having to resort back to JavaScript. So it was extremely difficult to say, you know, HTTPlib2 or URLlib2, go grab me some HTML, and I want to render it in this browser object. Because Mozilla has all these funky things with Chrome. So obviously it doesn't let you just grab files from anywhere, even though you're running in Chrome. So I got really frustrated with that quick, because I want to build, you know, tools. So what I started to do more of was like WebKit development using PyQt. With WebKit, you can use a WebView and set HTML from another lib. The reason you'd want to do that, obviously, is because we're testing stuff. So we want to make sure that we have control over every single part of the request. Because just like he said earlier, you know, a lot of times tools don't give you enough context around what you're doing. So by writing your own client, obviously, you have all the context you need and you have all the visibility. So here's a couple lines of code in PyQt to instantiate a web view. Does anybody want to tell me what this web view does? I was just seeing it.
It's pretty easy.
Yeah. I was just waiting for an answer. This is audience participation, man. You're supposed to speak up. So some things like testing for cross-site scripting are a little easier to do from a web perspective rather than just seeing it, you know, in code and say, hey, did this get echoed back to me? So that's just one instance of, you know, exploiting a cross-site scripting vuln with this. But you can make a request with any lib you want to and render it. You might have a bunch of saved requests in like a SQLite database or something. And you might have like show HTML source in one pane and then render it in another pane. I mean, that's pretty common. So as you can see, you can do that in just a couple lines of code. It's basic. Some other things you can do. WebKit's getting a little more interesting on like the PyQt front. You can instantiate an inspector on an object, which is kind of cool if you want to like view into like the HTML source and see all the syntax highlighted stuff. But they're also allowing more access to Python inside the browser object itself, which is cool when you start looking at plugins like Silverlight and Flash and all that. So it's coming along. This support's getting much better for it every day. So that's going to be definitely a place to watch. SOAP-based web services are still out there. I mean, we still run into them all the time. One of the things that I've noticed is that there's really no good tools for testing SOAP-based web services. So there's a lot of vuln scanning companies who tout their web services testing, but has anybody ever like peered inside, other than the people that work for the scanning vendors that are here, has anybody ever like peered inside the logic for scanning web services to see what it's actually doing? Probably not. I mean, I don't think many of us do. But what you can do with like suds, which is a module for Python, is you can create an object out of a WSDL and then start calling functions out of that very easily. So since it has an object API, it makes it very easy to call its methods. It uses, go back one. It uses URLlib2 for opener support. So since it's using URLlib2 underneath, that means it supports proxies, it supports different types of auth, supports, you know, all the things that URLlib2 supports. And it supports basic auth like right out of the box. So if you specify username and password, it's going to submit that.
That's a finding, right? Basic auth.
Yeah, it should be a finding, yes. So to read and print the content from a WSDL is easy as 2 lines of code. And to perform functions based on the WSDL there, that goes out and converts some currency. So let's do something a little more realistic. So here, what we did is we pointed it to a WSDL that we wanted to test. We created our custom transport because we want to handle everything out of the request, right? So we decided to set our own user agent, our own cookies, and our own basic auth token from a previous request. We installed the opener, and then we started to send our values. So this would be a lot better. Oh, okay, so there's no line continuation on here, but the SQL vals equals that's coming from the PyFuzz, PyWebFuzz project, the imported FuzzDB. So that's why it's like gnarly and long. But so what this will do is it'll iterate over the top of that, calling the get credit card service, and run through those tests. And when you run that, what you see is a lot of responses. But you can see how some of them actually brought back data instead of none. Those are credit card numbers, so that's probably not good. Luckily, that was WebGoat and not my bank. Although it could be my bank and I just don't know about it. They don't let me poke around there.
So working with Flex, Flex is a framework for developers to develop web applications on top of the Flash platform. One of the features of Flex is being able to serialize messages into the AMF format. It's just some compact binary format. It's the action message format. Several tools out there support AMF. Tools like Burp, Charles, WebScarab. It's great. However, the downside to these tools is that I found is you can't really craft messages from scratch, and you can't add properties to AMF messages. So one of the modules out there available for Python is PyAMF. It has the AMF encoders and decoders that allow you to serialize Python types into action message format. So take, for example, like a Python datetime object. That'll get serialized into an AMF datetime, which then, when BlazeDS, the remoting server, receives that, it'll decode it into like a Java util.date object. With PyAMF, we can write clients and remoting gateways. Django and Twisted have support, so you can actually write Python web applications that serialize content to AMF. So if you remember from last DEF CON, one of my buddies, John Rose, wrote a tool called dblaze. It went ahead and enumerated remoting methods and services on a Flex remoting server, one at a time, just by brute force. One of the things that I noticed diving into Flex is an AMF envelope can contain multiple AMF requests. So I just thought, like, hey, why not just stuff all those AMF requests in one? And I could just do all that enumeration in just one HTTP request. So that's one of the cool things I did, as well as like assess the entire Flex app in one one HTTP request. So you could fuzz the entire app. Hopefully it doesn't break halfway through your requests. But it's one of the things you could do really easily with a couple lines of Python. You might run into, you probably will run into cases where the Flex client is actually passing back custom objects to the server. So like say you have some employee object. When your proxy goes to actually try to deserialize this, it's going to choke on it because it doesn't know the structure of that object. So what we could do in literally 4 lines of Python is create an object factory. And this object factory is just basically a dictionary behind it. And then we just register that class with an alias, a class name alias, so that when PyAMF goes to encode or decode that object into an AMF stream, it encodes it as, say, that employee object versus just some dictionary. So that when the server then gets it, it knows that it's an employee object and not a dictionary or a hash map or whatever, and it works. So that's that.
Has anybody in here ever done any Iron Python? Ah, I stumped you. How many people know what Iron Python is? Okay, I didn't stump you. Iron Python has tight integration into .NET. And there's a couple of cool things you can do for it. Obviously, we didn't have enough time to like go into all this. But it can be your friend when you're doing .NET stuff. Basically, you can import the common language runtime from .NET and then start calling functions out of the common language runtime, just standard .NET functions in Python, as well as be able to take .NET DLLs and call functions out of those as well. So if you're doing like Silverlight, if you're accessing a Silverlight app, you can pull right through those. If you've ever heard of .NET Reflector, I mean that's using like a lot of the .NET reflection libraries. You have the same amount of access to the, well, I shouldn't say exact same, but you have pretty much the same amount of access to those as well. So you could basically build your own reflections functionality inside of Python. So if you wanted to like create a small tool that goes out to the web and hits a Silverlight app, takes the zap file down, unzips it, goes through the manifest and looks for all the DLLs and then imports them, you could do something cool like that. It's extremely simple. You just say import common language runtime and then add the reference to the DLL and then do a standard Python import statement for those functions. And then just start calling the functions. Pretty easy. So as you guys probably run into testing applications, probably have run across a binary protocol here or there. You know, just because it's over the web doesn't mean it's all HTML. We did use binary before web. So you know, when you get this binary protocol, it's really easy to want to give up. And you know, what do you do without your scanner? Your scanner is not going to be able to test this now. And you know, we could all apply the Miller fuzz to this, which will find probably vulnerabilities in the parser of the binary protocol, but we might not explore or not be able to have the chance to explore deeper code paths as we would if we were able to actually decode that binary protocol into an actual message structure that we can work with. So Python has a Struct module which allows us to pack Python values into associated C structures. So this is just a simple binary protocol I just whipped up as an example. A couple things to note. It's like real common amongst binary protocols is you have like type markers that indicate the type that follows. Strings would just have a following the type marker, the length of the string, and then the string itself. Strings encoded in UTF-8. Numbers would be encoded as doubles, say in network byte order here. And our type markers are basically shorts or unsigned 16-byte integers. So when it comes to parsing a string, basically, you know, when we indicate that our current position in a stream is that type marker, we can just unpack the next value into a short to get the length of the string. And then we unpack the string based on the length, so we actually have that value of the string there. Writing a string,
So going into reverse and actually sending stuff to the server now. Basically, it's just the opposite. We encode our string into UTF-8, get the length of a string, write our type marker, and then write our string with the length of the string preceded before the string, and that's it. So when we actually create all these methods for parsing booleans, numbers, strings, and other maybe more complex objects that your binary protocol actually implements, basically this is what it's going to end up looking like. We iterate over every byte in a stream. Based on the type of based on a type marker that we run into, then we do the associated protocol parsing. And what we actually did now just is create some simple state machine. And there you go. So writing a protocol parser is a lot easier.
That was like perfect timing. There you go.
So,
so a couple of other things you might have noticed. Pretty much everything we were talking about here will work in either Python 2x or 3. The URL lib modules have been merged. And if this just isn't enough for you, we haven't really came out and formally said this yet, but we're actually writing a book on this topic because this is a humongous topic and it's hard to do in like an hour, right? So we're writing a book on this, and we're going to go because there's farther things you could go down, like using the base HTTP server class to then test browsers and do all that good stuff. So if you just can't get enough, well, hopefully in like 5 years the book will be out and it'll be already be invalid.
So we have 10 minutes, which is a lot more than we actually allotted for. So if you guys have any questions, I just learned Python as we were talking about this, so I don't know how much help I could be, but be happy to answer any questions you got.
Flip to the next one. So if you care about, what did you do? Man, you broke it. How did you do that?
I don't know. Some weird feature.
Okay, so if you care to listen to us run our mouth on Twitter or whatever, that's our info. And we'll be walking around, and if you have, does anybody have any questions right now? Oh, yeah, it's...
So the question was, can we provide the URL?
The URL,
again? Yes, we can.
Thank you for clarifying. It's hexsec.com, hexsec.com/docs. And it's obviously the two top docs on there. So that's the presentation you just saw, and then the code snippets that contains the Burp API, the Reflect Request program, Dharma encoder, and the PyWebFuzz. And Dharma encoder and PyWebFuzz are on Google Code, which is great because you get to submit bugs, and then I get to not fix them. It's awesome. Any other questions?
Yeah. The presentation
is it's up there.
Is the first link
on
that page.
Sorry that it's not too verbose like with what it is. We literally did that like right before coming down here. So I'm just like, yeah, say Black Hat USA 2010. It's quick.
Any other questions?
Wow, it was that explanatory, huh?
Awesome.
Awesome. Anyway, thanks for showing up and watching our PHP talk.